Hello and welcome to this next lesson. Hopefully you could see me. My gear is not the best for recording. So anyways, I'll just sit here and look like a weirdo, whatever. Hey, if you sent me a video yesterday, thank you. I really enjoyed those videos. So it's good to see your faces. I'm glad you're all doing well. What we're going to do is we're going to go over ways for solving more exponential equations. So this is 7.7 roughly. I'm going to attach homework 7 at the end of this, and you can do that for homework today. How about we start with a warm-up? I've got 2 problems for you. Why don't you go ahead and pause the video? You know how to do these problems, so pause the video, work these 2 problems out. If you recall, the way that you could solve this is by finding a common base. Because if you have the same base raised to different powers, but if they equal the same thing, then you could say that the exponents would be equal as well. So why don't you pause the video, do these 2 problems, and then you can check your answer with mine. Okay. Hopefully you got these answers. Let me walk you through this real quick. So here I had to try and find a common base to solve this problem. As you can see, 5 squared is 25, and so I can replace 25 with 5 squared. Now that they have the same base, if this exponential equals that exponential and they have the same base, then that means that their exponents must be equal, which means that n plus 10 does equal 2. And so then I could solve for n, subtract 10, I get n equals -8. How'd you do? Thumbs up? Right on. How about this one? Well, first you need to find a common base. 9 squared is 81. And so 9 isn't going to work as the common base. But what I can do is I can turn this 9 into 3 squared, because 9 is 3 squared. And I can replace this 27 with 3 cubed. And so once I do that, I use properties of exponents to distribute this 2. Remember, when you raise a power to a power, you multiply. And so here I'm multiplying a plus 2 times 2, which means I can just distribute that 2. I get a to the 2a plus 4. 2 times 2 is 4. I do the same thing here. 3 times 4a is 12a. 3 times 2 is 6. Now they have a common base. And if these 2 exponentials equal the same thing and they have the same base, that means the exponents equal the same thing. And so I set these equal and I solve for a. How'd you do? So recall, we have done this before. We've solved equations like this before. The next question is, well, hey man, what if I can't find a common base? And, of course, I'm glad you asked that. If you can't find a common base, then you need to, well, for example, here, let me give you an example. What about 2 to the x power equals 61? So there's no way of expressing 61 in some base 2, in some 2 to some power. And so we're not going to be able to find a common base here. But we can use the principle of log equalities. What the heck does that mean? I'm glad you asked. Well, if log base b of x equals log base b of y, what am I saying here? I'm saying if you have 2 logs that have the same base and they equal each other, then what does that say about their inputs? What does that say about x and y? Well, if they equal each other and they have the same base, that's the most important part, then you could say the inputs are equal. It's very similar to this property. If you have two exponentials with the same base, you could say the exponents are equal. This is very similar. And so if you have this scenario, then the inputs equal each other. And so we could use this principle and we could sort of like use it backwards to solve a problem like this. How do we do it? Well, once we get it down to two terms, like one exponential equaling a number, then we can take the log of both sides, so to speak. So let me take this example for you. If I have 2 to the x power equals 61, well, I can use this property in reverse. So this is like saying 2 to the x equals 61. That's like saying, okay, x equals y, and now I'm going backwards. Meaning I could use both of these as an input to a log with the same base. Input of 2 to the x equals log of 61. Notice what I did. I just put this as an input into a log and that as an input into a log. Now these have to be equal. Why? Because the inputs are equal. Notice I used a common log, and I did that because that's on my calculator. I want to go the easy route, right? And so once you get to this point, we need to use the property of logs to get this exponent out of the log, because we're trying to solve for x, right? And so we need to use let's see, what's it called? Power rule? Yeah, power rule. Power rule of logs. To go ahead and expand this, okay? The power rule says if you have an exponent inside of a log, you could just sort of like take it out and put it in the front, right? So x times log of 2, all of that equals the same thing as that, because we use this power rule of logs to expand it. So this is going to be the key part in solving these problems. You get it to have like one term or one exponential equaling one number. You get it down to something equals something. You take the log of both sides. Once you do that, you could use properties of logs to take the exponent, to take the variable out of the exponent so that we can solve. And then from there, you're just going to leave everything in log form. You could type these into your calculator, but let's wait till the end. Now to solve for x, I just need to divide both sides by log 2. These would cancel, right? If I divide this by log 2, these would cancel. And then I just have this log of 61 divided by log 2. And now that is what x equals. And you just have to type this into a calculator. And you know what? I need a calculator, so... Okay, let's see. All right. So, anyways, if you enter this into your calculator, your calculator finds log of 61, then divide that by log of 2. Now, do not put these into your calculator before you solve for x, because if you do so, and if you find this value, and you round it to some number, I don't know what this is, but I don't know, let's pretend it's 4.857. Usually logs will produce numbers that kind of like go on forever, right? And so you don't want to round just yet, because then you'll be rounding twice. And you want to type this whole expression into your calculator and then round. Let's round to the nearest 4 decimal places, okay? The nearest, what is that, 10 thousandths or 10,000 place? Yeah, let's do 4 decimal places. Do not round until the end. Anyways, if you type that in, hopefully you got 5.9307. That's what x equals. And we could go back. We could plug this into the original and find out, oh, we got the right answer. But I'll let you do that if you like. Anyways, here are the steps to solving exponential equations using this method of taking the log of both sides. Step 1, you need to combine the exponentials that have common bases, and you need to combine your constants. And so let's take a look at this example. We'll do this one together as well. Step 1, I don't have any other exponentials. It's just this one, 7 to the nth power. And so what I need to do is I need to combine my constants. And how do I do that? Well, I need to isolate this exponential by dividing both sides by 4. All right? We're using, same way that you know how to solve equations, right? But now we're just isolating the exponential. We need to get that by itself. And so when we divide that, those cancel. And we get 7 to the nth power equals, what is that? 37, I believe. 37. So once we get it into exponential equals like a number, once we get it into something equals something, then we can take the log of both sides. So step 1, you combine your exponentials that have common bases, combine your constants. That's what I did here. I basically isolated my exponential. That's step 1. You get it into something equals something. One thing equals one thing. And then step 3, you take the log of both sides. And so here, if these two are equal, then that means that the log of 7 to the n power equals the log of 37. And then, this is the most important step, step 4, you use the power rule of logs, which says, if you have a log base b of a that's being raised to the x power, well, that equals the same thing as just bringing that exponent out front and multiplying. Remember? And so we need to use this property because this is what's going to get our variable out of the log for us to solve. And so here's step 4. I'm just going to change this and do n times log 7. There you go. I'm just bringing that n out front. Equals log of 37. Step 5, you solve. We still have to watch for extraneous solutions because logs can't have negative inputs. And so let's take it back to this level here. If this 37 was negative, then I can't take the log of both sides because I can't have a log of negative 37 because you can't input negatives into logs. And so you still need to watch for that. If you end up having an extraneous solution, it'll be when you get like a negative. At the stage where you take the log of both sides, if you have a negative that you're ever inputting into a log, then you can't solve. No solution. It's an extraneous solution. And so make sure you're looking out for those, okay? Anyways, well, one more step. We need to divide both sides. All these problems will be like the same. Same process. Towards the end, you're going to be dividing usually just 2 logs. And we use the common log so that we can use our calculator. Now, if you type this into your calculator and round, I don't know if I'm running out of space, so I'll do it here. If you round, you'll see that n equals, what did I get? 1.8, let's round 4 digits after the decimal, 556. That's what n equals. And so anyways, these are the steps that you're going to need to solve these equations. I'm going to post the properties of logs. I'm going to post the properties of exponents because you might have to use those to do your homework. But basically, this is it. Please, if you have any questions, I'm going to post a discussion along with this. There'll be a discussion. You'll see it. If you have questions, please ask the question in the discussion board so that everybody can see it. If you need to record yourself asking the question, then, that's great. I hope you do that. Sometimes it's easier to ask a question like live, But if not, you can type. Please, please, please ask questions if you have them. So long, farewell. All right, two more examples, and then it's all you. So here I have an exponential. I have 5 to the p power, and I want to solve for p, right? And so I need to isolate this exponential. Currently, this one term, this exponential itself, is being multiplied by -2. And so this whole thing is one term. I need to isolate that. And so first, I want to subtract 7 because this is PEMDAS, right? The order of operations, we kind of have to go backwards here. First, we want to subtract before we divide by this -2. And so here I'm going to subtract 7. I'll get, what is that, -70 if I subtract 7 from both sides? Subtract 7, those cancel. Yeah, -70. And so I get -2 times 5 to the p power. Let me get rid of that. Equals -70. My exponential is not isolated yet. I need to get this -2 out of there. And so divide both sides by -2. Okay, great. Then I'll have 5 to the p power equals, what is that, a positive, what, like 35 maybe? Yeah. And so now I can take the log of both sides, and I get log of 5p equals log of 35. P comes out front. Divide by that log. Then you get p equals log 35 divided by log 5. You could type that into your calculator. I'm sure you could find the answer for yourself. But anyways, make sure you could do this problem on your own. And then how about this one? Pause the video and try to do these on your own before I kind of go through them. But anyways, hopefully you paused it for that one. So here, try it on your own. But anyways, first I need to divide both sides by -3. Because I need to isolate the exponential. Those cancel. Then I get 10 to the x plus 1 equals, let's see, I'm dividing here. What is that, -7? So now I have exponential equals -7. If I take the log of both sides, which is what I'd have to do to get the exponential out of exponent spot, if I take the log of both sides, then I'll be inputting a negative into a log, which, no, you cannot do that. No. And so, because that's the case, this is actually no solution, because that's an extraneous solution. You can't input negatives into logs. No, so, solution. No solution. So, anyways, those are two examples. Please ask questions if you have any. Your homework is posted.